Hello there, Math 112 fans. Let's finish up this little review series. We're going to do, this is Winter 2018, Problem 3. Just continuing to try to make sure we understand these big ideas of chapters 10 and 12. Now, I've already said in class that the question you're going to have on the quiz this Friday, this is in the Winter 2025, is going to be question 2 from this quiz. I said it in class, I handed it out, I announced it, but I've gotten a bunch of emails about that. People saying, is that what you said? So you can also watch a video. We went through all of that. My real goal is for you to be able to leave this course and be able to analyze a function. And so I've now done a lot of problems like this. You need to make it clear in your mind, because this is first off, you're going to need to know this stuff to do well in the exam next week. And this quiz is trying to get us to start that process and on the final. But just when you should be able to analyze functions if you're going to go on into business and econ and other things. All right. If you're going to do a business example, you have to remember several things from class. And you're doing a lot of this in the homework, and we did this in lecture as well. The main things to remember are the initial conditions for our business functions. So let's kind of recap what those are. So one thing that's always true is that if you sell 0 items, you make $0. $0 come in. That's an initial condition a problem won't tell you. You need to know. What are the other ones? The starting cost is what we call fixed cost. We saw that in Math 111, but even if you didn't take Math 111, it's something we've seen this term. And this problem is telling me that's 15. The only other thing is profit at 0. Now, profit at 0 has to be revenue minus cost. So it's going to be 0 minus 15. So profit is negative 15 when we start. So in this problem, we have the initial condition. So I just wanted to state that up front. We know where everything starts. And this first question is an antiderivative question. So let's review antiderivatives and how we use initial conditions. Now, there's one other thing I need to address, which kind of has surprised me this week. I encountered 4 different students that had this problem. And so before I do the problem, let's address something, which is, and I don't know if this student was just scared to tell me, but I've had quite a few students that said they don't know what e to the 0 is. And so that's something you're going to need to know for this problem and for quite a few of the homework questions. In fact, it's come up several times throughout the term. So you've had to deal with this already. So it appears there's some issues with understanding about exponents. When I write 2 to the 1, it means 2 to the first power, 2 times itself. When I write 2 squared, it means 2 times 2, which is 4. 2 to the 0, we could talk about and have a long discussion, but you've definitely encountered this before, that it's 1. There's nothing special about 2. I was just giving an example. E to the 0 is 1. Now, that was you needed that in Math 111 when you were dealing with bank account problems. So this is an expected prerequisite, that you know e to the 0 is 1. It's something that pops up in these problems in a moment. But I realized that I encountered 4 or 5 questions that didn't know that. Students that didn't know that, and so that's something we need to have in our toolbox. Okay, so let's summarize what this question told us. This question said that I'm telling you marginal revenue, which is the derivative of total revenue, and I'm giving you the formula for it, which is 7e to the 0.02q. I'm also telling you the derivative of total cost, which is q squared minus 12q plus 124. In addition, I'm giving you initial conditions. The initial conditions are that total revenue at 0 is 0. So you have to know that. And total cost at 0 is 15. They told us that. So then how do we finish this question? We integrate. So this is in our integral rules, something we've done quite a bit in the homework. So let's recap how that goes. This is this integral of 7 e to the 0.02 q dq. And that's one of the rules we've been talking about over the last week or so, which is that the integral of e to the ax dx is 1 over a e to the ax plus c. And that looks like I'm trying to get off my screen here. Okay, so there we go. So that's what we're going to use to write the following. So this is going to be 7 over 0.02 e to the 0.02 q plus c. And I'm just going to move this down a little bit. And then let's look at this. Now, if you do, moving a few things, if you divide by 0.2, you can do this in your calculator. It actually comes out, does it come out kind of nice? 2/100. Ah, yes, 350. So this is 350 e to this, and you can use a calculator to do that if you want. Probably worth your while in the homework to do that division. Okay, so here's where we're at. Now somebody's asking me about this on the discussion board. They're saying, I don't know how you got 350. I thought this was supposed to be 0. That's the question they're asking. So let's talk about what initial conditions mean again. They don't mean that C is 0. They mean you have to plug it in. So this means that when you plug in 0 for Q, which would be 350 e to the 0 plus c, that you get 0. And this is what I was talking about. You need to know that e to the 0 is 1. That is a prerequisite for this course, but it's something you can quickly remedy if you don't remember that. So this is 350 plus c equals 0. So c has to be negative 350. And that gives us our function. So our total revenue function, let me just give ours a little more space here. Scroll up a little bit. So our total revenue function is 350 e to the 0.02 q minus 350. You can check your work by saying, what happens when I plug in 0? When I plug in 0, I get 350 e to the 0 minus 350. So I get 350 minus 350, which is 0. So that has to be 350, or else you don't get that 0. All right, I hope that answers that question. Let me know if you have follow-up questions on that part. Now let's integrate this one. Let's just do it in one swoop this time. So this is 1/3 q cubed minus 1/2, so it's going to be 6 q squared plus 124 q plus c. Now in this case, when we plug in 0, you still should be thinking about it as plugging in 0 and having it equal 15. But in this case, when you plug in 0, you get 0 minus 0 plus c is 15. So here C should be 15. I think that was confusing students. They were like, how can you put a 15 here and not put a 0 there? It's the same thing. It's just in this case, when we plugged in 0, they all were zeros. So the total cost at Q is 1/3 q cubed minus 6 q squared plus 124 q plus 15. Okay, so I hope that answers that question. I think this question is stemming from one of two problems, which is either assuming that C is the starting value, which isn't right, or not knowing that e to the 0 is 1. So I hope I've dealt with that. Okay, let's talk about the next question. So the next question says, what is the biggest and smallest that marginal cost can be? So this is more of an exercise in reading and doing what the question says. So here the question's about marginal cost. Now that sometimes confuses people. They're like, isn't marginal cost the derivative of something else? It doesn't matter where marginal cost comes from. If a question's about marginal cost, then marginal cost is your starting function. So the very first thing I would write here is they're asking me. Now there's a separate question of what that means, but the question's not asking us to interpret that. It's just saying consider that function, which it was earlier, it was q squared minus 12q plus 124. That's our function. That's like our f of x, or in this case, f of q. What is it asking about that? It's asking about a maximum, smallest and largest, and it's asking us over an interval. So you should have a plan of attack for how you do those sorts of questions. Okay, so in the end, you're going to plug in to your original function and see which thing wins. You should already know that you're going to plug in 0 and 10. So at the end of this question, you're going to plug in 0 and you're going to plug in 10 and you're going to see what this gives you. Now, when you plug in 0, you get 124. When you plug in 10, you get 10 squared, which is 100, minus 120 plus 124. 100 minus 120 plus 104. So that gives you 104. So at the moment, this looks like the biggest, and this looks like the smallest. Zoom that out a little bit. But can we do better? So now we need to look at the derivative and when it's equal to 0. To see if this function has any other critical values we need to consider. 2q minus 12, we set that equal to 0, we get q equals 6. So there's only one other value we need to consider, which is what happens when we plug in a 6 here. So it's going to be 6 squared, which is 36, minus 36 plus 124. Not 36, what am I doing here? 6 times 12. So 72. So this is going to be 72. So it's going to be 124 minus 36, which is 88. So at the end of this question, we found out that at the endpoints, we got 124 at the first endpoint. At 6, we got 88. And at 10, we got 104. This is the smallest. This is the biggest. So we would call this the global max, and we would call this the global min. But the moment we had a function and an interval, and we were asking what is the biggest and smallest, we landed in one of our topics from chapter 10. Okay, that's the one situation where you plug back into the original function just to see what is the biggest. So we talked about that a bit today in class, but I hope that clears things up a little bit. Okay, last question. It says the following. Recall that average cost is total cost divided by Q. Determine if average cost is concave up or concave down at 1. So now we're talking about average cost. That's our starting function. Unfortunately, I don't think it's been written yet. We do have total cost. Let's grab it and move it down here. Come on. So here's total cost. All right. We need average cost. That should be the very first thing we write. How do we get average cost? We need to divide this by Q. Now, if we divide it by Q, I would just simplify. We're going to divide the first term by Q, which makes it 1/3 Q squared. We're going to divide the second term by q, which makes it 6q. We're going to divide the third term by q, so we get 124. And we're going to divide the last term by q, which makes it 15 over q. But since I know I'm about to do calculus, I would rather write it as 15q to the minus 1. Okay, now that's our original function. That's what the question's about. So we're being asked about average cost. And what are we being asked about average cost? How and in what way are we being asked about its shape? We're being asked if it's concave up or concave down at a particular value. So I think if you haven't caught this yet, whatever your original function is, you can think of that as height. Like if you plug in and you wanted to graph it and got a number, you could think of that as the height of the function, right? So if I plugged in a 2 or something into this and you had a graph, that would tell you that height if this is AC. The derivative tells you the slope. So the slope of this thing is going to be 2/3 q minus 6, the derivative of this is 0, minus 15q to the negative 2. That means slope. So at a given point, that tells me what this is. So it's yet another bit of information about my graph. We've been dealing with that for a while. The second derivative tells you another little bit of information about your graph and its shape. So let's write down what it is. 2/3 plus 30 q to the negative 3. It's something we call concavity. And we've just tasted a little bit of what it can tell us. But the main thing is, if it's positive, it means it's part of a smile or concave up. And if it's negative, it's part of a frown. Okay, so what is this question asking? It's asking, is it concave up or concave down at 1? Now, in this case, you don't need to set it equal to 0 because it's not asking you to find when it's concave up or concave down. It's just asking what's happening at 1. You just need to plug in 1 and figure out if it's positive or negative. Now, in this case, it's positive. It's going to be 30 plus 2/3. So this is going to be positive. And so that means it's going to be concave. The original function is going to be concave up. In fact, if you could graph this, it's going to look sort of like what I have here. So that was a very particular, something that's asking you if it's at a particular value, if it's concave up or concave down, is asking you whether the second derivative is positive. Okay, so I'm going to stop it at that. Do let me know on the discussion board if you have follow-up questions about this. But hopefully that cleared up a few additional things.